go. Okay, first thing, I'll keep reminding you of this. Don't read fast. You shouldn't be racing through the AP test. You won't get a good score. Like, go slow, be deliberate. So this one, not a whole lot to read. It just says, here's F. So that's nice. I can just jump right into the question. So go to part A. Part A says, show that F is continuous. Now, we had one very similar to this on the 2012. To get the points, you have to use the definition of continuity. So you have to use limit statements. If it's multiple choice, you don't have to use the notation. But because it's FRQ, you do have to have the right notation. So you need to say, as they've written here, the limit from the left of the function. If you put this, that's fine. If you put f of x, that's fine. You would have had to figure out that that limit is 1. The way I would figure out the limit is I'd say, okay, I'm plugging in a value here that's close to 0, but not quite. So I'm trying to remember the sign of a number that's just a little bit less than 0. So I remember the circle. Angle 0 is over here. So an angle that is slightly less than 0 would put me like here. Well, the sign is the y-coordinate. That y-coordinate is still very close to 0. So 2 times 0, pretty close to 0. 1 minus, that's why I get 1. We need me to talk through that limit again. So just glare. Correct. They are expecting you to use the limit.
So you can't go ahead and just do what I did. I just did this table with the x and part of this. That wouldn't.
Yeah, the table is the right logic. 2 pebbles here and here. The table is the right logic, and it works great on a multiple choice. But on an FRQ, where they want you to show, they do expect to see the limit statement. Good question for Jessica. F of 0. I think they would give you 1 of 2. Like if you did both limits and you use the limit notation, they'd give you 1 of 2 points. To get the third, you have to find the value at 0 as well. And then have this concluding statement. That's what proves that the function is continuous. Please, Jeremy. So, like this one question, part A, 2 points. Yeah, good question. Anybody else? 2 pebbles for Jessica and Jared.
What are the 2 different points for?
So ideally, you would have done what they show here, and you get both points. If you haven't done all of this, I kind of have to just hear what you did, and I'll let you know whether I think you got 1 or not. So.
This on mine, I had, so I didn't say about it, but I have the whole equation for 1, and I had f 0 equal 1, therefore x.
What is that?
I think they're like,
Yeah, they were really close to that one. Right. Sorry.
I did for
Pretty good. 1 and 2. They're looking, they don't have the negative and the positive signs here on your notation. So that's a little bit sketchy. And then you didn't have a concluding statement. You didn't have this statement here. Yeah. So I think 1. Jared. Yeah, I know what you mean. So you're like Brooke, to be honest. The logic is very good. And on a multiple choice, it's perfect. But they want to see those limit statements. They might give you 1, though. I'm not positive, but maybe 1 out of 2. So I get 1 from, I got the answer. Yeah, they want to see those limit statements. They probably would give you points for that. Brooke? I think my best guess would be 1 out of 2. Like they can see that you're doing the right thinking, but they really want to see that notation. So I think it's 1. Okay, next one. Okay, hey, key thing here, read slow. For x not equal to 0, not sure why they said that, but I'll kind of make a little note. Express f prime as a piecewise function, period. Okay, on the AP test, don't go past the periods, commas, question marks. Don't read more, because then you're trying to keep track of too much. Just do what they've asked. They want you to find f prime. It's a really simple idea. Here's f prime as a piecewise function. Therefore, the derivative is a piecewise function. So I write f prime of x equals, you're like copying this. Let's see. The derivative of 1 would be 0. The derivative of sine is the cosine, so that's just negative 2 cosine x. And that would be true for all x. Here we go. Can equal 0, so it's just x less than 0. Question, please.
If you did less than or equal to, would you lose a point?
Yeah, they would deduct a point there. They'll probably still give you one of the two, though.
Okay, yeah, 'cause the rest of it I got fine, but I just.
No, that's, I could see making that mistake for sure, myself. Yeah, I don't, yeah. I'm trying my best to empathize, because I really can. If I were taking the test, Eliza, I think I would have done exactly what you did. Just wouldn't have even thought about it, so. Here's a reminder, though. You might want this on a flashcard. When you're taking a derivative of a piecewise function, there's a decent chance that there's a corner where the two pieces meet. And that's what's happening here. And that's where they're telling you you can't find the derivative at 0, is that it's meeting in a corner. So, question? So when you have a piecewise function, it's common for the two sections, the two pieces, to meet at a corner. Doesn't have to be, but they can meet at a corner. If they meet at a corner, you can't find the derivative at the corner. That's why there's no equal sign here. And they kind of gave that as a hint. So, anybody else? For Brooke and Eliza, any questions? Okay, so I've done that, and yes, that was worth 2 points. Find the value of x for which f prime of x is equal to -3. So, hey, eyes up here, everybody look, come here. Key to the test is you go slow, you read, if you think of something to do, you just start doing it. If you're just stuck thinking, it's time to do something else. So when I read this, find the value of x, so I'm supposed to find out, like I plug in an x, and I get this to equal -3 or this to equal -3. So I thought of something to do. I can try and solve that. So I can say -2 cosine of x. I'm supposed to make that equal -3. So let's see, put the 2 over there. So the cosine of x, I want that to equal -3 over 2, negative. So that means the cosine of x is supposed to equal 1.5. Again, going slow, here's what you notice. The cosine can never equal 1.5, because the cosine's values are always between -1 and 1. So this can't happen. Like there's no value for x that will make this, no value for x that will make that equal -3. So I try that one now. If you're thinking of things that can be written legitimately, mathematically, you're not just making things up, then you keep going. Otherwise, you do something else. Don't get stuck. You should spend no time on the test just pondering until you've done a whole bunch of work. Once you've done a lot of work, then you can kind of ponder ones where you're stuck. This would be -3/4. So now to solve that, I take the natural log to both sides. So now I have e, no, just -4x, or -4x is equal to natural log of 3/4. Negative divided by negative is positive. Does that make sense? Ah, I got you. And I would stop right there. That's full credit. So that would be the third one. Question? Please.
Negative.
You're okay. Hold on, I just want to write it down. So you have x equal, read it exactly.
Potential log of negative 3/4 of the
Like this? Let me just stare at it for a second. How did you move the negative? I'm not saying it's wrong, but I don't know how it moved. I can't see that. This was positive?
Yeah, that's
So that was a mistake. Yeah. Okay. So yeah, this would be positive. Thank you for holding your question. Other question? Next. Find the average value of f on this interval. So straight from my flashcard memory, I remember to find the average value of anything. I'm going to integrate over the interval, 1 over the width of the interval, and I integrate what I'm averaging. So that's where I start. That's just straight from your flashcard memory. Question? Now I've got to do something with that. So here's f. So f has 2 pieces. So I need to break this integral into 2 pieces. So this is going to equal, don't forget to use equal sign appropriately, the integral from -1 to 0 of that thing, 1 minus 2 sine of x. Because integrals deal with the idea of being infinitesimally close, you don't have to stress about the fact that we're really starting just a tiny bit after 0. It's good enough mathematically. So anybody have questions to that? Please, Jessica.
So, I was thinking, I typically split it into 2, but then, you guys see, you go like from -1 to 0, and from 0 to 1, there's like, just 1 over 1, is gonna be
Oh, like you split the...
Yeah.
Yeah, mine suits you. Hold on a second.
Do that?
I got you. Like you found the average of each piece.
Oh.
Like you did 1 over 1 for this integral plus 1 over 1 for this integral. Hold on a second. Yeah, here's the problem. It may be the same. I'd have to think about it. What you're really doing is you're finding the average of this section, and then you're finding the average of this section. You're just adding them together. Yeah, you're trying to find the average of everything. So that's the flaw in that reasoning. Now, you would get this point because it says, does the student have these 2 integrals written down? And you do. And if you do this part right, you're still going to get 2 more points. So you're still in a good place because you're likely to get 3 out of 4. 66% is a 5, so you're doing great. Because you got 75%. That makes sense? You're probably wise.
So what I did is I distributed that 1/2, and I just had 1/2 of this. About 5.
Oh, yeah, that's totally fine.
And then also, I don't have the equal sign.
Right here.
Yeah.
I think they forgive you for that one. Yeah, that's okay. I was simply stating, Eliza, this is equal to this.
Yeah, I wrote that, but
I think you're okay on that. The way you're doing it, it's easy to follow, so I think you're fine. Pebbles, anybody else? So we keep going. So this is going to be 1/2 I need the antiderivative. Antiderivative x, sorry, 1 is going to be x. Using Susie's circle, this is going to be, see the negative, so that'd be plus now. 2 cosine of x. That needs to be evaluated from -1 to 0. And so I need another parenthesis, so I know it's 1/2 times all of it. Plus, see, ax plus b rule. So 1 over -4 e to the ax plus b from 0 to 1, close parenthesis. Question? Something's bothering you, which you
So I got the first half of it right, but I don't have the -1/4.
So they'll give you 1 here,
One.
because you have one of the two antiderivatives.
So
Then you lose this because of that mistake.
why do you have the -1/4?
So the rule I have in my memory, in my flashcard memory, is that the antiderivative of e to the ax plus b is 1 over a. Did that answer your question?
Yes.
Can you remind me, so if you have a numbers that are 2, 3, 4, whatever, you can't derivative that to get 2x.
Yeah.
So I understand. I want to make sure
A
that.
good way to check it there is just think to yourself, well, what is the derivative of x? It's 1. So yeah. Question 2 comes for Ryan. Anybody else? Oh, please.
Can you pull the circle thing again? I don't remember that.
No worries.
well.
So, invented by a student, her name was Susie Lynn. She thought of this pattern, and I'll have you help me, Eliza, it'll make it stick in your memory better. So she thought of a circle and said, okay, where is sine equal to 1 on the unit circle?
Sine is 1 at 3.
Nice. So again, the more you can make one memory link to another, the easier it is to remember. So cosine's 1 where? Perfect. So then these are easy. And now the way the circle works is if you're going this direction, call that clockwise, the derivative of sine is cosine. The derivative of cosine is negative sine. Anti-clockwise, antiderivative. Does that answer your question?
Yeah.
You're welcome. 2 pebbles. Anybody else? Next one. Back to here. Okay, the good news is now, because it's an FRQ, all I have to do is plug everything in and make sure my parentheses are in the right places, and I get the last point. Put a 1/2 here, parenthesis. I need to plug in 0 for x, plus 2 cosine of 0, minus, parenthesis again, plug in -1, plus 2 cosine of -1. Be very careful with parentheses. Plus, now this section, so that's 1 over -4, e to the -4 multiplied by 1, minus, parenthesis, 1 over -4, e to the -4, plug in 0, close that parenthesis, and I need another parenthesis to close that. That's the last point. You don't have to do anything else. Just write that down and get the point. No. The rule of the AP test is algebraic and numeric simplification is not required. So they'll even leave, you can even leave cosine as just as written. So that's the last point. If you worked it all the way out to its most kind of easiest form, it would look like that, but you don't have to. Please, take.
If you attempted to simplify but you had that already written, would you lose the point?
You will.
Okay.
And that's the wisdom of just stopping.
So it's more, yeah.
Yeah, better just stop because you already got the point. If you go further, you just risk losing it.
Yeah.
So. Super Hayden, anybody else? Cool, next thing. I think, is there more? That's it, right? Oh, sorry, you're good. Go back. You're good.
So the 4 points are for what?
So the 4 points are, 1, did the student come up with the fact that we've got to do these two integrals.
Okay.
This one and this one.
Right,
So that's one point. Did the student correctly identify the antiderivative of this integral? That's the second point.
okay.
Did the student correctly identify the antiderivative of this integral? That's the third point. The final point is, did they understand how to plug everything in? Okay, excellent. Let's go.